Hi there. All right, today we're going to be talking about elements. All right, so in this lecture, we're just going to tell you a little bit about the periodic table and about how the different groups in the periodic table relate to each other and what their characteristic properties are and things like that. This is important because the entire universe is made up of elements, and so it's going to be a lot of fun to get you into it. A lot of this will be review from physical science. But I think you guys will be happy to have that little bit of review taking place, and we'll connect to the elements today, okay? All right, so let's get take two. Okay, here we go. Objectives. We want to make sure we understand the places where we can find metals, nonmetals, and the semi-metals, or we call them semiconductors or metalloids on the periodic table. Talk about their characteristics. And then we're going to tell you the difference between families and periods. Remember, one of them is going to be up and down. The other is going to be left and right, columns versus rows. And then we'll talk about the elements that you might want to memorize. We are not going to have to memorize any this year. But if we were going to have to memorize some, those would be the ones we'd want you to memorize because they're the most commonly used ones. Okay? All right. So 51 elements. Boom. Don't worry about it for this year. And because you've got an online and an open resource kind of quiz and test, you're not going to have to worry about memorizing those. All right, so here are some interesting ones, though. Each year, students will oftentimes ask, why is it named like that? And so here's a couple examples of why we might name certain elements some very unusual things. So, for instance, if we take something like gold, which has the symbol AU, well, a lot of those weird names come from the original Latin. So Latin for gold back in the old days was aurum, okay? Tungsten is a W. That's one that's a lot of weird, oftentimes very weird for students. And that's from the German word for tungsten, which was wolfram, okay? So depending upon, what language they might have used at certain points in time, the different scientists might have chosen that symbol to represent it. And then sometimes, and we actually don't have any of these right now on the current periodic table that we're using, but sometimes they're going to use these symbols that are three-letter symbols, and these are just the first letter root words of the digit. So if I said unum pentium, well, basically that's just the way of saying 115. And so sometimes you'll have that. Right now, we don't have any of those because we have all of the 118 known elements are actually named at this point, which is not something that has happened for a while. It's been that way for about a year and a half, 2 years maybe, but it's definitely unusual. Remember that all of our symbols must have a capital letter, okay? So it always starts with a capital letter. And if there's going to be a second letter, that second letter needs to be lowercase, okay? So sometimes we're going to take the first letter of this element, the element name. Sometimes it'll be the first two. Sometimes we want to take the first and third letters. They come up with different things. Tin, we didn't talk about that one. That's Latin for stannum. So lots of different fun element names that we've got there. Okay, so these are the regions of the periodic table that we want you to be familiar with. Notice how there's like a lot of pink here. That's the metals. Most of the elements that exist are metals. The periodic table is made up of a lot of metals. So we've got a lot of metals here, and those are actually broken into some smaller groups we'll learn later. And then we've got this little orange group right here. Those are the metalloids, or the semi-metals, okay? The semiconductors, a lot of times we call them as well. And then we've got this green group here, along with the purple group. Those are all non-metals, but this purple group has a special name, and that purple group is called the noble gases. Okay, so we'll come into a little bit more detail on some of those names later on, but all of these are non-metals, but noble gases are a particular category of those nonmetals. All right, so let's talk about groups versus families. Families are, groups and families are the same thing in this case. Families are the columns, okay, the up and down, and groups are the same thing. The reason that we call them families is because all of those things kind of have similar characteristics. The things that are in the same column have similar characteristics to each other, just like you might have some similar characteristics to your family members. Okay, so similar chemical properties. And then the horizontal rows, the ones that go left to right, those are called periods. Okay, so we have families or groups, and then we have periods. Okay, the periods are going to slightly change in their characteristic properties as you go from left to right. Okay, their properties, both physical and chemical, are going to change a little bit, and it's kind of regular. They kind of increase a little bit. Sometimes they dip down a little and then go up again, but they're pretty regular changes. All right, so this is one of those pause points, right? So you can read this and see if you can answer these questions, and then we'll talk about it here in just a second. All right, pause. And we're back. All right, so another element in the same group as selenium. All right, well, we better go back and look at that periodic table, right? Boom, boom, boom. Come on back. All right, so selenium. Well, first of all, you've got to figure it out, right? Whether it's selenium. And this is where it becomes helpful to have memorized certain elements on the periodic table. Because if you know where selenium is, then you're going to be able to answer this question quickly, right? But you can look for it. It's just that it's not named, right? So you have to have a periodic table that actually has the names listed as well. But that's selenium. Now, if we want to find something that's in the same family or group, then we can choose oxygen, sulfur, tellurium, polonium, right? So that's kind of what you would do for that one. All right, we've got to skip through some questions and then skip back again. And then we have sodium is an element that reacts violently with water. Name another element that might also have this property. Okay, so if it has a similar property, it's going to be in the same family, right? So I've got to find sodium, Na. This is another one that goes back to a Latin root. It's called natrum. And that Na is going to have similar properties as anything up here, basically, okay? Lithium, potassium, probably rubidium, cesium, francium, not hydrogen. Notice that hydrogen is actually white here. And in some periodic tables, they can actually kind of interpret hydrogen almost being up there. It's a non-metal. However, at really high pressures and temperatures, like in the center of Jupiter, they believe that hydrogen actually turns into a metal. It kind of looks like mercury. So yeah, it behaves as a non-metal in our situation, in all of our conditions, but there are some conditions which will behave differently. Name an element in the same period as oxygen. Okay, so now we're in periods, right? So now we're going in the horizontal rows, going left to right. And so we got to find oxygen, and we can name any of these: neon, fluorine, nitrogen, carbon, boron, beryllium, lithium. Any of those would be in the same period. Okay, so now that you have checked your understanding of that, and I bet you did a great job there, let's talk about the different characteristics for all of these. So metals, elements that are good conductors of heat and electricity, basically, okay? Good conductors of heat and electricity, and they are going to typically be solids at room temperature, malleable, and ductile. These two terms are good ones to make sure you know. Malleable means that it can be bent into shapes, okay, hammered or rolled into sheets. Ductile means that it can be drawn into a fine wire. You know, when they actually make wire, they actually take big pieces of metal and they just have machines that pull it into tiny, tiny, tiny little wires. I always thought that they kind of like rolled it, but they actually will pull wires a lot of times to actually create them. So it's kind of cool. All right, let's see. And we're back. And they, one more time back there. Yeah, we already talked about that. Conduct heat and electricity well. Okay, so here is some examples of some metals. Okay, you can probably name this one, right? It's going to be copper wire. And this is a property that will, be ductility, because it can be drawn into a wire. This is that malleability. It can be hammered into thin sheets, right? Aluminum foil. And then a gold. Gold is the best conductor of heat and electricity. And this is why you'll find gold in computers, okay? They will use gold as something to allow for that electricity to move through it. Okay, so nonmetals, they're going to be poor conductors of heat and electricity, right? And they're going to have properties that are typically going to be gases, a lot of them anyway, right? All those noble gases, and then a lot of the halogens. They're going to be brittle when they're a solid. And again, yeah, they're not going to be good conductors of heat and electricity. And so if I try to zip a little piece of electricity through them, not going to work so well, okay? All right, so here are some examples of nonmetals. Here we have carbon, just kind of think of coal or charcoal. Sulfur, it's a nice yellow powder here. This is phosphorus. And you guys are familiar with red phosphorus, right? Might also be familiar with white phosphorus, found on the heads of matchsticks. And then this is iodine. It's actually a little bit kind of like blackish, darkish, purplish, and it will evaporate at room temperature. Slowly but surely, it'll actually, well, I won't say evaporate, I'll say sublimate. it'll actually go from a solid to a gas. But this metal is oftentimes used, non-metal, is oftentimes used in disinfecting a lot of your wounds and things like that for surgeries. Okay, then we have our metalloids, that third characteristic. There's not a lot of metalloids on the table, but they have the property of being somewhat metal and somewhat non-metal, okay? And so they are solids at room temperature, and they are going to conduct electricity better in certain circumstances than in other circumstances. And this is why we use these in computers, because there will be certain times when you want the electricity to really be pumping through, and other times when it's not something you really want as much. And so they use the semiconductor silicon in computers because it has the ability to conduct electricity at certain conditions that you want it to. All right, so noble gases. That's group 18 on the periodic table. These are unreactive. I like to say that they're called noble gases, even though this isn't true. I like to say they're called noble gases because they're like the nobility, right? It's a good way to remember it. Nobility doesn't want to have anything to do with the little peons down there, you know, the little people that are helping their, world be amazing. And so they are unreactive. They are not going to be dealing with the common folk. So that's the nobility. Now it's actually not the way why they're named that way, but it's easy to remember. So these are gases at room temperature. And your turn. All right. Real quick, back to noble gases. I always like to point out that these gases were not even known. These were the last elements to be discovered because they didn't react with anything, so we didn't have any compounds. Some of these were not isolated to be on their own to realize that they even existed until the mid-1900s. So it's pretty wild to think about something that was so common that it's all around us, but we don't even know it's there. And it was actually helium that was discovered first, and it wasn't discovered here on this planet. It was discovered in the sun first through its emission spectrum. So that's a fun little story too. All right, so let's classify each of these as far as what they're concerned. So a little pause point, and here we go again. All right, so the AR, far right side, argon, right? That's going to be a noble gas. SN, that's tin. You might remember seeing that earlier on. Tin is just to the left of those metalloids, and so this is going to be a metal. Again, most of the periodic table is metal, right? SB, another weird one, right? Antimony, that's antimony, I know, one of those weird Latin ones. But this one is actually in that little metalloid stair step, okay? You kind of notice the metalloids kind of look like a little stair step. That one is a metalloid, okay? Ca, calcium. Now you're thinking calcium, you're thinking bones. That's a metal, okay? Calcium by itself is not like your bone. It's actually a shiny, silvery metal. And hydrogen, again, weird because it's in that far left side of the periodic table, but it's actually a non-metal. Okay, so kind of a weird one there. All right, and another pause point, and you're ready to hit pause. Here we go, back to you again. All right, element in the same group as silicon, but it's a metal. Which element could this be? All right, well, we want to look at a periodic table again. So we're going to look at the periodic table over there. So, element in the same group as silicon, but it's a metal. Which element could this be? Same group. That means it's a family, right? So here we are in the family. Same group as silicon, but it's a metal. So can you think of any of these things are metals? Yeah. This is a metal. That's a metal, right? That's a metal. We are not going to pay attention to these. These are metals, but they're actually not in the same group. Okay, these little guys down here on a periodic table, they're actually going to be in a different place. It's actually kind of a little insertion point that we're going to stick all that stuff at the bottom, right in the spot right in here, okay? And so they put it on the bottom here just to save space on the wall so you can have a bigger periodic table without it being so long. So anyway, yeah, so hopefully you said on your answer, you said, where was it? It's the silicon. So you said tin or lead or fluorovium. Those would have been the answers for that one. Okay. Now, here I come back. Walk with me back to the board, please. Thank you. Woohoo! Here we go. Here we go. Carrying you. It's kind of hard to carry a whole class, but I'm pretty awesome. I can do that. Yeah. Okay. All right. Here we go. So let's kind of sum up what we learned today. these are our objectives. Can we now locate our metals, nonmetals, and semi-metals, or metalloids on the periodic table? Yeah, we can do that. Can we describe their characteristic properties? Yeah, sure we can, right? Whether or not they conduct electricity and heat well, whether or not they're solids at room temperature or gases at room temperature, things like that. Groups versus periods. Yeah, groups and families versus periods. You got it, right? All right, and then memorize. I don't have to do that this year. Aren't you lucky? If you guys do want to memorize some, it's great to do it. Yeah, let me know if you want to memorize the entire periodic table, because I always want to give you guys a little something extra. You know, if you want to memorize the entire periodic table, you deserve some sort of bonus. All right, well, thanks a lot for another great day. You guys paid such great attention to what we talked about, and I'm just so proud of you. Hopefully you got a good feeling for the elements. Again, we're going to get into way more detail on a lot of these elements as we go forward. All right, we'll see you later.